Hello, chemistry students. Today we will be performing our separating a ternary mixture experiment. In today's experiment, we will first be learning to separate the components of a mixture based on physical properties and reactivity. We will also determine the percent composition and percent recovery of a mixture. And third, we will learn the laboratory techniques of filtration. Let's get started. Okay, so the first thing we need to do is label two dry 100 ml beakers. So we have beaker number 1, and we have beaker number 2. We next need to determine the mass of beaker number 1 and beaker number 2. So the mass of beaker number 1 is 66.2669 grams. The mass of beaker number 2 is 67.4370 grams. We will next add between 2.5 and 3 grams of our unknown ternary mixture. Our unknown ternary mixture is unknown number 2. And I've already gone ahead and added between 2.5 and 3 grams of unknown number 2 to our beaker number 1. And the mass of beaker number 1 plus the unknown mixture is 69.0550 grams. Okay, so next we're going to extract the sodium chloride from the mixture by using a graduated cylinder to pour 50 milliliters of hot water into our beaker number 1. So I already have our hot water on the hot plate here. We'll add 50 milliliters to our graduated cylinder. And then we will transfer our 50 milliliters of hot water to our beaker with our ternary mixture. And then we'll stir for 2 minutes using a glass stir rod. We're next going to set up a gravity filtration apparatus. So in order to do that, we first need a piece of filter paper and a funnel. And we're going to be placing this in our funnel. And we need to fold our filter paper in half. And then we need to fold it in half one more time so we have quarters. And we'll take this folded piece of filter paper and place it in our funnel. And now we have our filtered funnel that we'll be using to filter our ternary mixture. So we've gone ahead and set up our gravity filtration system here. So we have our ring stand with an iron ring. We've placed our funnel in the iron ring and we have our filter paper inside. This is beaker number 2 that we've already previously taken the mass of, and we will be collecting our filtrate in beaker number 2. I've gone ahead already and moistened our filter paper with a little bit of deionized water. We're now going to decant our mixture from beaker number 1 into our filter funnel. You want to make sure that you don't pour your solution over the level of your filter paper. This process is called gravity filtration. Now, in order to rinse the remaining solid that's inside the beaker and get it all into the filter funnel, we're going to take our deionized water wash bottle, angle our beaker, and rinse that solid down into the funnel. And now we've transferred everything from our mixture that was in beaker number 1 into our gravity filtration funnel. And we'll allow this process to complete the filtration. At this point, all of our water has filtered through to beaker number 2. So we're going to set this aside. And we're going to take beaker number 2 and we're going to place it on a hot plate, and we're going to turn it up to high heat until we get a gentle boil, and we're going to evaporate off all the water in beaker number 2. Okay, so we have evaporated all of the water from our salt solution that's in beaker number 2. And so you can see all of the salt inside of our beaker number 2. So what we'll do now is we'll go ahead and let this cool to room temperature before we determine the mass of beaker number 2 plus the salt. You may also need to place it in the drying oven for 5 to 10 minutes. We've allowed our beaker number 2 plus the solid salt to cool to room temperature. We now need to determine the mass of beaker number 2 plus the solid salt. The mass of beaker number 2 plus the solid salt is 68.2497 grams. Next, we're going to take a clean, dry, evaporating dish. Here's our evaporating dish. And we're going to determine the mass of that evaporating dish. So the mass of our evaporating dish is 43.2952 grams. Okay, so we have our clean, dry evaporating dish here. And what we're going to do is we're going to remove our filter paper and take about 5 milliliters of deionized water and rinse the remaining residue on the filter paper into our evaporating dish. So I have a spatula here, and that's going to help us loosen up the filter paper. And we can remove the filter paper. We have our deionized water. And a pipette. So we're going to use about 5 milliliters of water to rinse the remaining residue down into our evaporating dish. So I've rinsed our residue into the evaporating dish, and we can now discard our filter paper. Next, we're going to add 8 milliliters of 3 molar hydrochloric acid to the solution in our evaporating dish. Okay, so we're going to slowly add our 8 milliliters of 3 molar hydrochloric acid to our evaporating dish. And when we do this, the reaction is going to produce bubbles of carbon dioxide gas, and we'll stir until the solution no longer bubbles. So we have a glass stir rod here, and we'll slowly add our hydrochloric acid. And we'll continue stirring until it is no longer producing carbon dioxide gas bubbles. Okay, so we're no longer forming carbon dioxide gas bubbles in our evaporating dish solution. So what we're going to do now is we're going to separate our liquid from our sand in the evaporating dish. So we have our beaker 1, which we've previously rinsed with deionized water. And we're going to pour our solution into beaker number 1 without transferring any of the sand along with the solution. I'm going to use a glass stir rod to help me here. We're going to transfer this solution into beaker number 1. And again, we're being careful not to transfer any of the sand. And then we're going to rinse the sand that's remaining in our evaporating dish with an additional 5 milliliters of deionized water. Okay, once we've rinsed our sand with the 5 milliliters of deionized water, we're then going to transfer the deionized water that we just used to rinse into our beaker number 1. But again, we're trying not to transfer any of the sand . Okay, so at this point, we have our sand remaining in our evaporating dish, and we have our solution in beaker number 1. What we're going to do next is we're going to need to heat our evaporating dish to drive off any remaining moisture that's in our sand. Okay, so we have our evaporating dish with our remaining sand. What we want to do is drive off the remaining moisture in the evaporating dish. So we're going to set up an apparatus here. We have a hot plate. We have a 250 ml beaker, about a third of the way full with deionized water. And we're going to take 2 glass beads. We're going to add them to our 250 ml beaker. And we're going to set our evaporating dish on top of the 250 ml beaker. Now what this is going to do is it's going to heat the water. The water is going to produce steam that's going to heat the bottom of the evaporating dish, and it will drive off the moisture inside of the evaporating dish with our sand, thus leaving us with just dry sand. If any of you are bakers out there, this is similar to a double boiler. So our sand has dried completely. There's no more moisture remaining inside the evaporating dish. So we're going to go ahead and remove that. And we need to dry off the bottom of the evaporating dish because there's a lot of water on the bottom. And then we're going to let this cool to room temperature before we determine the mass of the evaporating dish and the sand. So we've allowed our evaporating dish and the sand mixture to cool to room temperature. We now need to determine the mass of the evaporating dish and the sand. So the mass of the evaporating dish and the sand is 44.7264 grams. So we'll now take our saved supernatant in beaker number 1 and place it on a hot plate and set it to high and let it boil for 5 minutes. We've allowed our supernatant in beaker 1 to boil for 5 minutes. So now we are going to take 15 milliliters of 1 molar potassium carbonate. We'll measure this out in a 25 milliliter graduated cylinder. Okay, so we have our 15 milliliters of 1 molar potassium carbonate. We're going to use hot hands to remove our beaker from the hot plate and set it on a wire gauze. You always want to make sure you're not setting a hot piece of equipment on a cool surface because it could crack. We're going to turn off the hot plate. And then we're going to add our 15 milliliters of 1 molar potassium carbonate to our supernatant solution in beaker number 1. And we're going to stir this for 5 minutes. We've stirred our hot supernatant for 5 minutes. So now we're going to obtain a clean, dry watch glass. We're going to put our initials on the back. And we're going to add a piece of filter paper to the top of the watch glass. We're now going to determine the mass of the watch glass and the filter paper. The mass of the watch glass and the filter paper is 91.3780 grams. Okay, now that we have the mass of our watch glass and the filter paper, we're going to set up a vacuum filtration system. So what we have here is a Buchner funnel with a rubber gasket on top of a sidearm filter flask, and we have some tubing running to our vacuum port. Now our vacuum port isn't actually working today, so I'm going to take this side and we're going to actually pull a suction with an empty DI water bottle to get our vacuum. So we're going to take our filter paper and add it to our Buchner funnel, and we're going to moisten our filter paper with a little bit of deionized water. And then we're going to pull a vacuum to get that water through into the filter flask. Next, we're going to add our supernatant to our filter system. And again, we'll pull a vacuum. Okay, so now that we've vacuumed through our supernatant and collected our solid on the filter paper, we're going to continue vacuuming for about 5 to 10 minutes so that our filter paper and solid dries as much as possible. Okay, so we've allowed the solid to dry on the filter paper for about 10 minutes or so. So what we're going to do now is you would turn off the vacuum port, and we're going to use a spatula to carefully remove the filter paper from the Buchner funnel. And we're going to transfer this to our watch glass that we previously weighed. You can see we've transferred our filter paper to the watch glass from the Buchner funnel. You can see our solids on there. Now we're going to place the filter paper and the watch glass in a drying oven for about 15 minutes or so to get the whole thing dry, remove all the moisture. Okay, so it's been about 15 minutes in the drying oven, and our filter paper and the calcium carbonate are now dry. So now we will weigh the watch glass, the filter paper, and the calcium carbonate to determine the mass of the calcium carbonate. So the mass of the watch glass, filter paper, and the calcium carbonate is 91.9304 grams. You can now determine the mass of the calcium carbonate. So now you should be able to determine the percent composition and the percent recovery of all three components of the ternary mixture: the sodium chloride, the sand, and the calcium carbonate. Thank you for joining me for this experiment.